What's going on, you guys? All right, we are going to be doing the derivatives of inverse functions. So please remember for me from Poprical that arc sine, all that is sine inverse of x. So if you saw that as sine inverse, then arc sine is the same thing. Arc secant is the same thing as secant inverse, and arc tangent is the same thing as tangent inverse. Now these are the three. Sine and cosine kind of go together with this. They're very closely related. Cosine is actually just the negative of arc sine. Arc cosecant is actually just the negative of arc secant, and arc cotangent is just the negative of arc tangent. So these are the three that the AP test really hits. They don't care so much about the other ones. So notice I don't actually have what the derivative is of these things listed out because I want to show you guys how to kind of come up with the derivative on your own, especially if you forget, because these derivatives are kind of weird and as far as memorization, so I don't want to just like put it out there and say, here, memorize it. That is what some teachers do. That's just not what I like to do. I like to show you guys where they're coming from. So let's look at arc sine first. So I want to have y equals arc sine of x. Well, I do not know the derivative of arc sine if I want to differentiate. However, if I rewrite this, this is the same thing, as sine of y equals x. Right? And I know the derivative of sine of y, and I can do this now that I know how to do implicit differentiation. So what I also like to do is I like to say, if I have a triangle, then sine is opposite over hypotenuse. And I can use Pythagorean theorem to find out that my last side is 1 minus x squared. This will come into play in just a little bit. All right, so if I do the derivative of this, the derivative with respect to x, then what this comes out to be is cosine of y times y prime, right? Because we got to do the chain rule there. Don't forget that's the chain rule. The derivative of the outside times the derivative of the inside part, which would be y prime, and then equals derivative of x with respect to x, which is just x. So now, if I'm solving for the derivative, which is y prime, then I have 1 over cosine of y. So here's where the triangle comes into play, right? I know how my triangle is labeled here, but I do not know what cosine of y is. However, I do know that cosine is adjacent over hypotenuse, so if I go from y and I do the adjacent over the hypotenuse, then what that gives me is that cosine of y is the square root of 1 minus x squared over 1. Right? Cosine y, adjacent over hypotenuse. So then y prime, my derivative, is 1 over the square root of 1 minus x squared. And that's it. That's the derivative of arc sine of x. So this is 1 over the square root of 1 minus x squared. And that would be it. If we wanted to generalize this and say that I had the derivative with respect to x of arc sine of u, where u is a function of x, then this is u prime over 1 minus u squared. So it's 1 minus function inside squared times the derivative of the function inside. All right, that's just kind of thinking about this in terms of the chain rule. So there's our first one, right? So there is the derivative of arc sine. We're going to find the other ones very, very similarly. So let me get rid of all that junk, and let's come up with our other ones. So y equals arc secant of x. Well, similarly, I don't know what the derivative of arc secant is. However, if I rewrite this, this is secant of y equals x. So I'm going to go ahead and draw my triangle at this step, because I know it's going to come into play later on. Secant is hypotenuse over adjacent, which would make this side the square root of x squared minus 1, right, by Pythagorean theorem. Yep. So now the derivative of secant is secant tangent. All right, so if I do the derivative of that whole equation, secant y tangent y, and then I need my times y prime, right? right? Where all of this is all together times that y prime. So I need to divide over that secant tangent. So I could say y prime is 1 over secant y tangent y, which personally I like to rewrite as cosine of y times cotangent of y. Right? So now I need to do cosine of y and cotangent of y. So cosine is adjacent over hypotenuse, so that's 1 over x. And cotangent of y is adjacent over opposite, which is 1 over the square root of x squared minus 1. Now there's a little caveat to this one. The issue here is that my hypotenuse, this can never be a negative number. So if for whatever reason this x is a negative number, we need to eliminate that and make this a positive value. Well, the way that we make anything positive is by adding an absolute value. So this will simplify or be rewritten as 1 over absolute value of x times x squared minus 1. I don't need to worry about that x on the inside because the square will make it positive anyways. So that's essentially where that absolute value is coming from. So this is 1 over, let me do it in a different color so you can differentiate it a little bit better. 1 over the absolute value of x, square root x squared minus 1. All right, and same sort of idea. If I did this as arc secant of u, where u is a function with respect to x, then it would be u prime over u squared minus 1. Right, that is invoking the chain rule there. Okay, so now let's get to our third one there, where I have y equals arc tangent, or just art. Right, and then I want to rewrite this because again I still don't know the derivative of arc tangent yet. So tangent of y equals x, and let's do the derivative. So then the derivative of tangent is secant squared y times y prime using the chain rule equals 1. So y prime is 1 over secant squared. Well, I didn't draw my triangle, so I need to look back and base it off of this or this. Either way, makes no difference. But you need to recognize that y is your angle. So y, and then tangent is opposite over adjacent, which makes this the square root of x squared plus 1. Right, and then secant is hypotenuse over adjacent. So secant of y is root x squared plus 1 over adjacent, which is 1. So that would mean secant squared is just x squared plus 1. So y prime is 1 over x squared plus 1. Well, that's nice. That's a pretty one. I like that one. Right, and then if I want to generalize this one for a chain rule, it'll be arc tangent of u, where u is a function of x, u prime over u squared plus 1. All right, so these are your derivatives. Maybe you want to memorize them in this form. I'm not sure. But again, it's up to you whether you want to memorize those or whether you want to come up with it each time. Hopefully you're going to do enough practice on these things that you will have them memorized anyways. I need to do more practice on them too because I do not have them 100% memorized. I like coming up with them on the fly. All right, but find an equation of the tangent line for f at the given x value. So I have f here, I have x equals -1. So to find the tangent line, I'm going to need two things. I need the point and I need the slope. So I do know that I need my derivative, and the derivative of this is 1 over, let's verify it, x squared plus 1, right? Yep, x squared plus 1. So at -1, so f prime of -1 to find my slope would be 1 over 1 plus 1. So my slope is 1/2. I also need the point, so f of -1 would be arc tangent. Don't like writing arc, apparently, of -1. Well, that is the position, or the angle, right? The arc tangent, the outputs are angles. So please, please, please remember that these outputs are angles. Something else important to note, let me write this out real quick. Let me think about all of the ones that we need. Tangent inverse. The range is negative pi over 2 to positive pi over 2. Sine inverse. The range is also negative pi over 2 to pi over 2. And cosine inverse, but really in this case we want secant inverse, would be 0 to pi. Those are the places that I have angles for my inverse trig functions. Okay, so arctangent is negative 1 at positive pi over 4. This is all unit circle stuff. So again, if you need to refresh on that, I believe it is, oh gosh, I think it's section 4.6 in pre-cal. I can verify that. Maybe. Yep. Maybe it's 4.7. No, 4.6. Right. So if you want to, you can go YouTube, watch my YouTube channel for the 4.6 notes. That should be plenty to get you there as far as remembering how to do the inverse trig functions. If you want to talk about it with me, just talk about it with me. But I'm not going to waste everybody's time that remembers how to do this stuff too. All right, because we are learning calculus. Yes, we will probably all need a refresher on pre-cal. So please, 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 if you don't remember this stuff, let me know. Some of you guys will see this and be like, oh yeah, right, but it's pi over 4, but it's negative because we have to be in the fourth quadrant there with our unit circle. Right, our tangent only exists here and here. Since it is a negative 1, I know that my angle has to be somewhere down here. So that is negative pi over 4. So the equation of my line now, I have y minus, really plus, pi over 4 equals 1/2 times x plus 1. There's the equation of my line tangent. All right, arcsecant at x equals root 2. So f of root 2, arcsecant, I cannot write this, but f of root 2, so arcsecant of root 2, hypotenuse over adjacent, so this would be a pi over 4 angle for secant. And then the derivative is what? 1 over absolute value. Let's verify. Let's see, 1 over absolute value of x, square root x squared minus 1. All right, so at root 2 then, I have 1 over root 2, square root 2 minus 1. So this would just be 1 over root 2. That's all I need, so y minus pi over 4 equals 1 over root 2. I can't write a 2. 2, x minus root 2. You can simplify all that if you want to, but again, no need to if it is a free response, and all I'm doing is asking you to write the equation of the line. All right, find the derivative here. So again, this is just using the chain rule or other things that we need to use in order to find these derivatives. Like on part B, you can use the product rule or you can use the quotient rule, either way, but we're just finding the derivative, no reason to simplify it. So f prime of t, so this is u prime, right? Arcsecant derivative with respect to x of arc sine of u is u prime over the square root, right? Square root 1 minus u squared. Yeah. So 2t, right? Because that's the derivative of my inside function. Square root 1 minus t squared squared. So notice, right? This is 1 minus u squared. So u is my part inside. It is the whole t squared. So that'd be 1 minus t to the fourth. The derivative of u, right? This is with the chain rule. Goes up to the numerator because essentially this is 1 over square root 1 minus u squared times the derivative of the thing on the inside. That's just using that chain rule. So that's all I expect to see for a problem like this. Really, it's just the derivative. So it's going to be either 1 point or 2 points if we're feeling generous, if you get that derivative right or wrong. There's not really much leeway there. Okay, so g prime of x. Again, you can use the quotient rule here if you want to, or you could use the product rule. It really makes no difference to me at all. But let's see. So low d high. So low d high is at 1 over absolute value, yeah? No, it's arc cosine. I'm lying. I didn't want to do that one, actually. Which one did we do last? Sine. Let's do secant. No, let's do tangent. Yeah, okay. All right, so this would be 1 over x squared plus 1, I do believe. Yep. So low d high minus high d low, so that'd be just times 1, all over low squared. And that would be it for that one. Cosine, really the three that we're going to stick to are sine, secant, tangent. I should not have written a cosine one. Sine, secant, tangent, sine, 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 sine. Yep, okay. Slip up. All right, but that would be your derivative. I don't expect you to simplify. You don't need to do anything else. That would be your answer. All right. Natural log of t squared plus 4 minus 1/2. So still just doing the derivative. This first part really isn't that crazy. It's stuff you've been doing before. So 1 over t squared plus 4 times the derivative of the inside, which would be 2t. And then we have minus the arctangent, so 1/2. The derivative of arctangent would be 1 over 1 plus t over 2 squared times the derivative of the inside, which would just be 1/2. Right. You can leave it like that. You can simplify stuff if you want to. Really makes no difference at all. If it were me and I were you, I would just leave it like that. Yep, that one should be good. 25 arc sine. Yep. So y prime is 25 times arc sine is 1 over root 1 minus x squared. So 1 over root 1 minus x over 5 squared times 1/5 minus, all right, this one's ugly, but I would just treat it as 1/2 times, right, and then just do a product rule of the inside here. Just don't forget that this is 25 minus x squared to the 1/2. So derivative of the first, which would be 1 times the second, so 25 minus x squared, plus the first times the derivative of the second, so 1/2, 25 minus x squared to the negative 1/2, and then times the derivative of the inside, which would be negative 2x. And close all of my parentheses there. All right, so the derivative of arc sine is there. 1/2 u prime v plus u v prime. I think we are good with all of that. Yes. All right. Find equation of the tangent line to the graph of the equation at the given point. All right. So there's my equation at root 2 over 2 comma root 2 over 2. So I need to find the derivatives of these things. So let's see what we can come up with. So we have 1 over root 1 minus x squared plus 1 over root 1 minus y squared times y prime equals 0. Right? That is doing the derivative with respect to x of both sides. Of both sides. Right? Right. So then I would subtract over the 1 minus x squared. So this is 1 over root 1 minus y squared, y prime, equals negative 1 over root 1 minus x squared. Then I can multiply the square root of 1 minus y squared, so y prime is negative square root 1 minus y squared over root 1 minus x squared. And we've done these things in implicit differentiation before, right, that we have to solve for y, but I'm not going to do that in this case. There's no need to, right, because we're given the point, so we're given root 2 over 2 comma root 2 over 2. And really, since the point is the same in both of these, my slope should just be -1. But let's show it. All right, so that's the same thing. This is all the same thing, right? So it's the same thing divided by itself. So that whole part is just 1. So y prime at √2/2 √2/2 equals -1. I probably should have shown that on the last step too when I was substituting in my point. My apologies. All right, because I'm evaluating my derivative at that point. So my slope is -1. My slope is -1. I have the point. So the equation of the tangent line would be y minus √2/2 equals -1 x minus √2/2. There is my tangent line. All right, I'm going to pull up some AP style questions. Right, so the derivative of arc sine of this, so we would have 2x over 1 minus x to the 4th, so that should be option D right there. Right, this is just multiple choice. Let me make these go away. View thumbnails. I don't want to see that right now. Go away. Right, I guess I can just do this. Now they're away. Ha. Right, and then the derivative of arc tangent of e to the negative x, find e f prime of -1. So let's do that one. Let's work it out real quick. All right, so this is essentially a multiple choice question that you could see. So we would need to find f of x, f prime first. So f prime of x, arc tangent of e to the negative x, so that would be 1 over 1 plus e to the negative 2x times the derivative of the inside, which would be a negative e to the negative x. And then I can substitute in -1. So f prime of -1 equals 1 over 1 plus e squared times negative e. So hopefully we have negative e over 1 plus e squared as an option. Option C there. Oh, I went off the page a little bit. I'm sorry. Cool. I was waiting for questions, but you guys are not around to ask questions. So I will not wait for questions. Move that up a little bit and move you up a little bit. Arc tangent of sine of x. So we are doing arc tangent of a trig function. Pretty cool. So then f prime, right pen. You didn't just die on me, did you? It's going to die though. I may have to pause it and let it charge. So 1 plus u squared, so sine squared, times the derivative of the thing inside, which is cosine. And then I need to find f prime of pi over 3. So f prime, pi over 3, 1 over 1 plus, this is sine of pi over 3, squared times cosine of pi over 3. Right. So sine of pi over 3 is √3/2. So this is 1 over 1 plus 3 over 4, √3/2 squared, yeah, times cosine of pi over 3, which is 1/2. All right, and now knowing that this is a multiple choice, I need to simplify it. I'm going to guess it's that one, but I don't know. We'll find out. Let's see. Maybe not. Maybe it's 2/7. Yeah, it's probably going to be 2/7. Because I have 1 over 7/4 times 1/2, which is 4 over 7 times 1/2, which, yeah, it is 2/7. Well, 4 divided by 2 is 2, so it should simplify to that. All right, let's see what else we got here. Cosine of sine inverse. Then y prime is. Interesting. Cosine of sine inverse. All right, so let's see. I'm going to move this up and get a little bit more room. So y prime would be the derivative of the outside, which would be negative sine of sine inverse, which is arc sine, and then times the derivative of the inside, which is 1 over 1 minus x squared. All right, so let's see, what are my options? Well, here's the thing. So sine of arc sine, right, that's pretty cool because then it is just x. So this should just be this option right there. All right, so if you're doing the inverse of the function itself, then it's saying, essentially this is saying what angle gives sine to be x, and this is saying sine of what angle gives what. Well, sine of that angle is going to give the angle that gave us x. So all of that is just negative x times 1 over root 1 minus x squared. So negative x over 1 minus x squared right there. Option B. Interesting problem. Okay. Let f be the function given by this. So since I have an x to the x there, I know I'm going to need to do logarithmic differentiation. Make this a little bit bigger. So find f prime and write the equation of the line tangent at x equals 1. Let's see. So I'm going to do logarithmic differentiation. So y equals x to the, I'm going to call this arc tangent of x. All right, so that I have ln of y equals arc tangent of x ln of x. I'm going to move it up a little bit. All right, we have what we need so far. So the derivative of this left-hand side, if I do the derivative of everything with respect to x, such that I can find the slope of my line tangent, I would have 1 over y times y prime. And now I have this right-hand side is going to be the product rule. Should be able to recognize by now that two functions multiplying is going to give us the product rule. So the derivative of the first times the second plus the first times the derivative of the second. All right, and then I need to multiply that all by y, which y was x to the arctangent of x, so y prime is x to the arctan of x times all of this junk. So ln of x over x squared plus 1 plus arctangent of x over x. So not the prettiest thing in the world, but still not horrible, right? When it's all in terms of x, so that's pretty nice. And it was saying at x equals 1. So at x equals 1, right, here's the answer to part A. That's the answer to part A. And part B, I need to find y prime of 1, which would mean 1 to the arctangent of 1, which really doesn't matter what that is at all. 1 to any power other than 0 is going to be 1. So really anything to the 0th power is 1 anyway, so it doesn't matter what this is. But it will be pi over 4. So then I have ln of 1, which is 0, over 1 squared plus 1, plus arctangent of 1 over 1. So many 1s. So arctangent of 1, this is pi over 4. So 1 to the pi over 4 is 1. ln of 1 is 0, so 0 over 2. And again, arctangent of 1, this is pi over 4. So really, all of this simplifies to, let's see, 1 times 0 plus pi over 4. So all of that is just pi over 4. All that junk for that simple answer. That's ridiculous. Okay, so now I'm not done, right? That is the slope of my line. I have the x value, but I also need the y value of my point. So my function is x times tangent inverse of x. I wonder what my screen looks like right now. I just did wild things with my desktop. So x equals 1, x to the tangent inverse of x. So y of 1, I'm sorry, it was f of x, wasn't it? Yep, so I'm going to say f of 1. And that brings me to another point. We do need to be careful and I'm going to say off to here. Let me come back to this point in just a second. I would have lost a point on this problem, but let me finish this. So x to the tangent of x, so 1 to the tangent inverse of 1, which again, 1 to the pi over 4 is going to be 1, so this is the point 1, 1. So I have y minus 1 equals pi over 4 times x minus 1. That would be the slope of the tangent line at that point. So why would I lose a point? I would lose a point because I called my function something that it is not. I do not have y anywhere in the problem stem. It's fine for writing the equation of a line tangent, so they're not worried about that. But when I call f y in my work, they would probably be okay-ish with it, but I've also heard of them counting off points because I've now made up a different function that we are not necessarily talking about. We are talking about f of x. So when I do this, and I do this to make logarithmic differentiation easier, I should probably have stated let y equal f of x, or f of x equal y, either way. So that way, now that when I reference this, this y is my f of x. And I probably, when I wrote my answer down here, if I were taking the AP test, I would still want to say f prime of x is this, even though I did all my work in y. And they wouldn't have an issue with this either, even if we're using kind of two different types of y's, because it is just the y function of that line. They're asking for the line. This is what they would expect to see. Let's see if there's any more here that I would want to do. Nope, gets into the next section. So those are some good, challenging, more challenging AP problems that you guys could definitely see with different functions involved within each other. So hopefully that was helpful as well. But other than that, you guys have your homework online already, and let me know what questions I can do to help you out. Talk to y'all soon. Bye. All right, folks, so I thought more about this, and I do want you to do some more homework problems on these things, and some of those homework problems will involve the cofunctions. So the cofunctions, I know I said that you're not really going to see them, and you are probably not. But just in case, especially if you guys go into college, I should have thought about that, and I'm sorry. So I'm not just going to throw them out. So let's talk about the derivative of arc cosine of x. The cofunction is just the negative of the function in general, so 1 minus x squared. Really the reason being, kind of like when we were setting them up, if I do y equals arc cosine of x, and then I do cosine of y equals x, when I take the derivative of both sides of these things, the derivative of cosine is negative sine, so that's where that negative comes from. And then y prime, right? So that's where that negative is going to come from, and then it will be the same ratio still. It'll still work out that way. Arcsecant, the cofunction is cosecant, so d over dx of arc cosecant of x is negative 1 over absolute value x, square root x squared minus 1. And then arc cotangent is negative 1 over x squared plus 1. Right. Okay, so going back to this one that I said, don't do it. Let's go ahead and redo it real quick. But really the only thing that we need to adjust are the derivatives of my arc cosine there. Right, arc cosine will be negative 1 over root 1 minus x squared. And then it would be arc cosine of x. All right, so it's still the same thing as the original function. It is just the negative of your function. So, and notice when I was saying cofunctions, that's cofunctions from what we were talking about in pre-cal when we first introduced these things. If I have sine, let me do this in laser pointer. If I have sine and I have cosine, the only difference is one is positive, one is negative. I have secant and cosecant. One is positive, one is negative. I have tangent and cotangent. One is positive, one is negative. So as long as you remember you are not as, if you're not dealing with a co-identity, then you will have the positive form of that. All right, hopefully this was helpful as well, and I will see you guys soon. Bye.